angle side congruence. This is lesson 4.6b, and that means we've got 10 previous videos for chapter 4 that are in the geometry playlist linked in the description. So here's the angle side congruence theorem. It says if two angles and a non-included side of one triangle are congruent to the corresponding angles and non-included side of another triangle, then the triangles are congruent. So here we've got angle G that is congruent to K, and J is congruent to M, and we've got this side, HJ, is congruent to LM. And because of angle side congruence, triangle GHJ is congruent to triangle KLM. Now, we learned about the third angles theorem back in video 4.3c, and it says if two angles of one triangle are congruent to two angles of another triangle, then the third pair of angles are congruent because they're all 180 degrees inside, right? So we can use the third angles theorem to prove another congruence relationship based on angle side angle, ASA, which we talked about in the previous video, 4.6a. So we're learning right now about angle side, but we can use the third angles theorem and ASA as a proof for it. So here's a proof for angle side congruence using third angles theorem and ASA, angle side angle. So it's given that angle G is congruent to angle K, and angle J is congruent to angle M, and that HJ is congruent to LM. So we have an angle side, don't we? We need to prove that triangle GHJ is congruent to triangle KLM. So we're going to use the third angles theorem and ASA to do this. So our first statement is that angle G is congruent to angle K, that's given, and that angle J is congruent to angle M, that's given, and angle H is congruent to angle L. So we've got H is congruent to L because of the third angles theorem, which says if these two are congruent and these two are congruent, then these two are congruent. So now we can say that we've got a third angle that's congruent, right? So now we know H and L are congruent. Guess what? We've got an angle side angle. We've got ASA. We've got segment HJ is congruent to LM, and we've got triangle GHJ is congruent to triangle KLM because of angle side angle from steps 1, then 3, then 2. We've got an angle, a side, and an angle by using that third angles theorem. See that? And we started with angle side, didn't we? But that third angles theorem helped us with these being congruent, so we could do angle side angle. And we can use AAS to prove these triangles are congruent. So we've got this diagram, and if you look, we've got parallel line marks right here, don't we? So if you look at the diagram, our given says segment AB is parallel to segment ED. And it says that segment BC is congruent to DC. So we know these are two parallel lines, right? So if these are parallel lines, let me do this. If we've got these parallel lines, well, AE could be a transversal, couldn't it? We could also do BD is a transversal. So we need to prove that triangle ABC is congruent to EDC. So we're going to do a flowchart proof. And it's given that segment AB is parallel to segment ED. And that brings us to angle B is congruent to angle D. If this is congruent to this, then we've got angle B and D as congruent. Because if AE is a transversal, then this angle B and this angle D are alternate interior angles, aren't they? And that's our reason, alternate interior angles. We can also say angle A and angle E are congruent, because then we would have this one and this one as congruent, because we would be looking at AE as a transversal. And then this angle and this angle, A and E, would be alternate interior angles, wouldn't they? Okay? And then we've got it given that segment BC is congruent to DC. This one is congruent to that one. And that brings us to triangle ABC is congruent to triangle EDC because of angle, angle, side. All right? So when we're dealing with angle, angle, side, we have an angle and a side. See? This is congruent to this. These are both right angles, so we know they're congruent. And then we have a side that are congruent. So it's angle, angle, side. And for this one, you could say side, angle, angle, couldn't you? So you might see the AAS written as SAA. It's the same thing. It's just some books turn it around. It's two angles next to a side, okay? All right? So we can use AAS, that angle, angle, side, to prove the triangles are congruent. So take a look at this diagram. We've got segment JL bisects angle KLM. So this segment is bisecting this angle. And we've got that angle K is congruent to angle M. So this top angle is congruent to this one. We need to prove that triangle JKL is congruent to triangle JML. So we've got another flowchart proof, and we can start with a given here that angle K is congruent to angle M. That's given right here. And we've got our segment JL bisects angle KLM. That's given. This one brings us to the definition of an angle bisector, that KLJ, so this angle is congruent to this angle MLJ because that's the definition of an angle bisector. Our given brings us here, and we've got JL is congruent to JL, and we've talked about this before. This triangle here is using this side JL, and it's congruent to the side that this triangle is using as JL. And the reasoning behind that is the reflexive property of congruence. And that brings us with angle, angle, side, that the two triangles are congruent. So we can use the reflexive property of congruence to say a segment or angle has self-congruence when a side or angle is common to two triangles. So when you see they're sharing a side, we can use reflexive property, okay? Because it's self-congruence. This triangle is using this side and this triangle is using this side, so we say, you know, that it's congruent like that, see? Now, the other thing I wanted to point out is we're talking about all this ASA and AAS and side, side, side. There's no such thing as AAA or SSA, okay? Our next lesson is hypotenuse leg. It's HL congruence theorem. That's 4.6c. So we're moving along through these triangle congruence videos for chapter 4, and I hope you're doing well, and I'll see you next time. I think I almost tripped on my dog. Bye.